Hi, Assalamualaikum warahmatullahi wabarakatuh. In this video, I'm going to give you two more examples related to proving the trigonometric identities. So for the first one here, we have this equation, and I will start by considering the left-hand side of the equation. Okay, so consider the left-hand side. So here we have cosine of x plus 1 plus sine of x, and I'm just going to turn the denominator here into a simple fraction. Okay, we don't want to have an addition process. As you can see from the right hand side here, we only have a simple term, which is cosine of x. So based on that, what I'm going to do is I'm going to introduce a term here where I will multiply this term with 1 minus sine of x and 1 minus sine of x. So I'm introducing this term. Now you will see later on why this will work out. So by introducing this term here, this is actually manipulating it, and it doesn't change anything on the left hand side because this is actually similar to multiplying 1. Yeah, okay, so now I'm going to continue with this. I'm going to multiply, so cosine of x times 1 will be cosine of x. Cosine of x times negative sine of x will be negative cosine of x sine of x, and over here I will have 1 times 1 will be 1. Now 1 negative sine x will be negative sine x and 1, the term will be cancelled out, so I'm not going to write it down. Next, sine x, positive sine x, negative sine x will be negative sine square x. Okay, so next is I hope you can see that this one is identity. You can use the trigonometric identity where this one will be equal to cosine of x squared. Okay, this is the usual trigonometric identity which we have seen many times. So now I'm going to write down what we have here. Now on the top part, I think what we can do is we can factor the cosine of x. So I'm going to factor that out. So I have cosine of x 1 minus sine of x over cosine of x squared, so I can write down as such. And clearly from this you can see that this term can be cancelled out. So what we have next is a simplified form where we have 1 minus sine of x over cosine of x, and this is similar to what you've seen here on the right hand side of the equation. Alright, now let's move on to the next question, which is question B. Okay, so here I'm going to consider the left hand side again. Okay, so I'm going to consider the left hand side where here we have sine theta plus cos theta over cos theta minus sine theta. Okay, and for this question here, what I'm going to do is I need to do something. I need to manipulate this expression so that I have something that looks like cotangent theta minus 1. Now I need to have minus 1. Now if you compare what you have over here and what you have, okay, I'm just going to erase this first. Now if you compare what you have on this right hand side with what you have on this side here, you can see that we have the subtraction process. So now we're going to maintain just that. Okay, now here we have minus 1. So how can we turn sine theta so that it becomes 1? Now obviously what we can do is we can introduce or manipulate the whole thing so that I'm going to divide the whole denominator here with sine theta. Now why I'm doing that? Because I want to turn the term sine theta over here so that it becomes 1. So my first step is I'm going to introduce sine theta. So I'm going to divide the denominator with sine theta. So the whole denominator has to be divided with sine theta in order to maintain the balance of this equation, and because of that also the numerator has to be divided with sine theta. Like I said, why we are doing that is because we want to maintain the balance of the equation. When you introduce something on the bottom part, that something has to also be introduced on the top part. So the same thing with this one. You see, you introduce 1 minus sine x in the bottom part, so you have to introduce the same term so that this expression is like multiplying with 1, because this is actually something when you cancel out it becomes 1. So the same thing that we are doing here, we're doing the same manipulation. Okay, so now based on that we can simplify. So sine theta over sine theta, you will get 1 plus cos theta. Actually this one, let me just write it properly without skipping a step. Now so here we can separate the term. So we have sine theta over sine theta plus cosine theta over sine theta. So that's the numerator part. Now at the bottom again you can separate the terms. We have cosine theta over sine theta minus sine theta over sine theta. Now we can simplify that to be equals to 1 plus cos theta over sine. This is the definition for cotangent. So cotangent. For this one, this is also the definition of cotangent. Minus sine theta over sine theta is 1. So there you go. You have managed to show that this equals to the right hand side of the equation. Alright, thank you very much for watching. I'll see you in the next video.